As we are here today in Algebra II to talk about operations with radicals. When I say a radical, what do I mean? Like, what do you think of a radical? What's an example of a radical?
The
Square root. You were drawing it with your finger and then you said it. So very good. Okay. A square root is an example. Are there other radicals? Cube root, fourth root, right? But some of the key concepts that we've learned about a radical, like let's say we had the nth root of a times b. Now usually in most problems, what is n? N is which number? 2, right? The square root. And if it's a 2, we don't write it. But if it's anything other than a 2, we do write it. So the square root of a, or the nth root of a times b would be equal to, how would I break that apart?
Square root of a times square root of b.
Not the square root, the nth root.
of a and times the root of b.
Right? How about if I had the nth root of a divided by b? What would that be?
Nth root of a divided by
Nth root of a over the nth root of b, right? And what you remember then is that we always have to reduce our radicals. Like, what are things that you're always going to do in math from now on? Anytime you have a fraction, what do you do to the fraction? Reduce your fractions, right? 4/8 becomes 1/2. You reduce your fractions. You can never have a what in the denominator? Radical. So you have to multiply both sides by that radical to get it out of the denominator. And you reduce your radicals, right? So if I had the square root of x to the fifth, what is wrong with the square root of x to the fifth?
It's not reduced.
Yeah, well, it's not reduced, right? So I would need to break this up into what times what?
X is 4 times.
Yeah, the square root of x to the fourth times the square root of x to the first. So x to the fourth, x to the 1 is x to the fifth, and then this becomes x squared square root of x, all right? And you've got to do that with both numbers and variables. You've got to reduce your radicals. You have to not have a radical in the denominator, and you've got to reduce your fractions. So how do we know when things are simplified? How do we know when things are simplified? If you're told to simplify, okay, and this would be like the nth root of a times b, you want n as small as possible, and we will talk about that, n as small as possible. The radicand, that's the thing underneath here, the radicand contains no factors that can be brought out, right? And so what we saw is if I had the fifth root, or let's say if I had the square root of x to the fifth, that is not simplified because I can have x to the fourth come out as x squared. So I've got to bring things out from under the radical. Because the radical causes problems as you're trying to solve it. So you want to get as much stuff out from under the radical as you can because it'll make future things easier. Okay? No fractions. No fractions in the radicand. Okay? And no radicals in the denominator. No radicals in the denominator. So let's look and see what I mean by no fractions in the radicals. So if I had the square root of 1/2, is this simplified? No. What's wrong?
It's fraction.
There's a fraction. So what should I do so that there's no fraction under the radical? Square root of 1 over square root of 2. Now what problem did I solve? Now I what? No fractions. Okay, but am I done? No. What's the problem? Yeah, I've got a square root of 2 in the denominator. How do I get How do I get rid of that? What do I multiply the denominator by? Square root of 2. Can I just multiply the denominator by the square root of 2? No. Got to multiply by the square root of 2 over 2, because I'm really multiplying by 1, and that's allowed. And then I have the square root of 1 times the square root of 2 is the square root of 2 over the square root of 2 times the square root of 2 is the square root of, which is 2. Okay. Is there anything else I can do to simplify? No, there's nothing else that I can do. Okay, let's look at another problem. And you guys, this doesn't go away. Reducing these things does not go away. You've got to keep doing this over and over and over for next year, for the rest of high school, for the rest of college. Okay, so let's look at another one. Let's say I have the square root of 16 p to the 8th q to the 7th. Is that reduced? No. What's the problem?
60, you can get 4.
Okay, so you want me, and we got to go by point, right? So the 16, it'll do what?
4.
It'll come out as a 4, so I got that. Now what do I have to deal with? P to the 8th comes out as a what? P to the 4th. And what you can see is really there's a 2 here, and it comes out by taking the power and dividing by the power here, so it's P to the 8 divided by 2 is 4. Right? Okay. What's my problem with Q?
It's odd.
It's odd, so I should break that up into what?
Q to the 6.
6 and 6.
Q to the 6th and
Q
to the 1. Now Q to the 6 comes out as what?
absolute value.
Q to the 3rd, and remember we put absolute values when the power goes from even to odd, times, and I can't do anything else, I'm left with the square root of Q. So I've gotten everything out of there that I can, right? I've gotten everything out of there that I can. Yes?
We wouldn't need to do anything to the other Q because it's still in the radical, right? Like we don't need to put anything around it because it's still in the radical.
No, it's still in the radical, so you don't put, very good question. The Q the Q started out odd. Wait a minute. Q started out odd and stayed odd, so I don't have to do those, I'm sorry. That's only if it starts even and goes odd. Okay, so I wasn't paying attention, I'm sorry on that. Okay, so let's do another one. All right, so let's say I have the square root of x to the 4th over y to the 5th. What's the first problem that I should deal with? I got a what? Okay, so what are you going to make this? Square root of x to the 4 over the square root of y to the 5th. Now let's deal with the numerator. The numerator, is that going to be easy or hard? What does it just come out as?
X squared.
X squared. And then what happens down here?
Square root of y to the 4th times y.
Square root of y to the 4th times y. Now what am I going to end up with? X squared over what?
Y squared.
Y squared, because that comes out as y squared, the square root of y. Am I done?
No.
What is my problem?
It's a square root.
Yeah, so what do I need to multiply this by? Square root of y over the square root of y. So I have x squared, square root of y over what?
Y.
Okay, square root of y times the square root of y is y, times y squared is y cubed. Yes? Okay, we see how to do that. Okay, now, this is the problem. All right, this is where you've got to not mess up. So I'm going to show you something now that you're going to mess up over and over and over if you don't pay attention to. Right, you can't have a radical in the denominator. So what if I have 1 over the cube root of y? What is the problem here? What? There's a radical in the denominator. And this is where you're going to mess up. I was always, if there was a square root in the denominator, I'd multiply by the square root, right? If there's a square root in the denominator, I'd multiply by the square root. But this is a what? And I can't just say, this is what you're going to do, but this is wrong. Wrong. You're going to say, multiply by the cube root of y over the cube root of y, right? Because when it was square root, you multiply by the square root, okay? But the cube root of y times the cube root of y is not y. Do you see that? Think of this. The cube root of y times the cube root of y. What would that equal to? That would
the cube root of y squared.
the cube root of y squared. I'm missing a what? I'm missing another y under here. So you see, when this isn't square root, this won't get rid of it. Okay?
So you have to multiply by that again.
Yeah, you have to multiply it again, or what you have to see is, how many y's do I need?
3.
How many do I have?
1.
So underneath here, how many y's do I need?
2.
Y what?
Squared.
Cube root of y squared. Now I have the cube root of y squared over cube root of y times the cube root of y squared is the cube root of
Y cubed.
the cube root of y cubed. And so now I have the cube root of y squared divided by y. Boom. We've got that done, right? We've got that done. Okay, let's move on. Let's work one like that a little harder, but a red flag should go up anytime it's not a square root, and make sure that you do that step right. Okay, I'm going to have the fifth root of 5 over 4a. Okay, the fifth root of 5 over 4a. What's wrong with this?
Fraction.
It's a fraction, so I need to make this what? The fifth root of?
5 over the
The fifth root of 4a. Okay. Can I do anything with the fifth root of 5? No. It's the fifth root of 5. Okay. Now, am I done? No. What do I have to deal with? Yeah, I've got to deal with the denominator. So, I need to multiply it by, it's still going to be a which root? Fifth root. How many 4a's do I need?
5.
How many do I have?
1.
How many do I have to put here?
4.
And it would be 4a to the what? 4th. And then to make it 1, I've got to do the numerator the same, the fifth root of 4a to the 4th. Okay? So now let's look at this. What do I have down here?
The fifth root.
The fifth root of 4a, the fifth root, well, let's put it in here. The fifth root of 4a to the 5th, and that's going to be what? 4a. Now let's go back and work on the denominator. Okay, I'm going to have the fifth root of 5 times the fifth root of what?
4.
Okay, that's 4a times 4a times 4a times 4a, right? 4a times 4a times 4a. So what does that equal? 4 times 4 is 16. 4 times 4 is 16. What's 16 times 16? Somebody put that in their calculator if you can't do it.
256.
So this is 256 a to the 4th, right? So down here I've got 4a. That's good. And now up here I'm going to have the fifth root of what is 5 times 256? It's what?
1,280.
1,200.
1280.
1280. A to the 4th over 4a. And let me see. Okay, now, to make this easier, this 4, we can divide this 4 into 1280. If I divided this by 4, to get it underneath there, I would really need to divide by what? By 16, right? So I could divide out this as a 16. So what's 1280 divided by 16? Does that make sense what we're doing?
80.
Okay, so it's 80 a to the 4th over what? A. Does that make sense? 1280 divided by 16 is 80. Does this make sense?
Why do you have it divided by 16?
Okay, because it's divided by 4, so this would be, imagine, a 1/4 out here. If I want to move this in, it's, oh, no, that's a 5th root. That was a mistake, huh? Okay, that was a mistake. So, what we're going to do is we're going to see, is there any 5th power that will come out of 1280? That's the way we need to do it, right? So what is, the best chance would be 2. So let's say 2, 4, 8, 16, 32. Will 32 go into 1280? Well,
Yes.
how many times?
40.
Okay, 40. So I'm going to bring out 2 times the 5th root of what's left? 40 a to the 4th over 4a. Does that make sense? So we brought out 2 to the 5th, okay, and we're left then with 40 inside, and it comes out as a 2 over 4a. Are we done?
No.
Oh, so you have to find.
Just 5th root of 48 over 4 over 2a.
Okay. Stop and make sure you understand what we did. All right. So this is 4a down here. So we have to reduce this. The a4 is already less than the 5th root, so I can't do anything here, but there is a perfect power of 5 that I can take out. 2, 4, 8, 16, 32. So 32 is 2 to the 5th. And if I take 32 out of 1280, what am I left with? What am I left with? Does that make sense? So then what I've got is the 5th root of 40, a to the 4th, over 2 over 4 becomes 1 over 2a. And we're done. Do you see that? Does anybody have a question on that? Okay, so let's look about how we would, sometimes when we multiply, after we multiply, then we have to go in and we have to reduce after we multiply. Okay? We got to reduce after we multiply. So if I have 6 times the cube root of 9n squared times 3 onto the cube root of 24n. Okay, remember that's the cube root, not 3 cubed, it's a cubed root. So I have 6 times 3 is what? 18 times, and you guys make sure, you see that's not drawn good, it looks like it's 3 cubed. Make sure that you're not making it look like 3 cubed, that it's the cube root of 24n. So this is the cube root. Now the n squared times n is what?
N cubed.
N cubed. 9 times 24, who's got a calculator?
216.
216. All right? So the 18 we've taken care of. What's the cube root of n cubed?
N.
So we can bring that out as an n. And then I got the cube root of 216. Does 216 have a cube root?
Yes.
What?
6.
It's 6, right? 6 times 6 times 6 is 216. So this is 18n times 6. And now we just got to multiply 6 by 18, and that's what? 108n. Okay? Does that make sense? All right. So that's how you multiply. The multiplication is easy, but then you've got to make sure that you what? Reduce the radical after you've done that. Okay, so now let's see. This is something you have to see about adding radicals. What if I have the square root of 3 plus 2 times the square root of 3? What's that equal to?
3 square root of 3.
3 square root of 3. It's like 1 apple plus 2 apples is equal to what?
3.
What? 3 apples. What is your apple?
3.
Square root of 3. Okay. So this would be 3 on the square root of 3. All right?
So there's just like an imaginary 1 in front of you.
What?
There's just like an imaginary 1 in front of you.
Yeah, it's like an imaginary 1 in front of it. Good. Okay, now let's think about this. What would the square root of 3 plus the square root of 6 be?
2 square root of
Square root of 18.
No, not at all. That's like saying, what is an apple plus an orange? An apple plus an orange is what?
No.
An apple plus an orange. So what can I do with this?
Nothing.
Nothing, because it's not the same. I can add 2 apples and 2 apples and get 4 apples. I can add 5 apples and 3 apples and I can get 8 apples. I can add 1 orange and 3 oranges and get 4 oranges. But I can't add an apple and an orange, right? Those aren't the same. Okay, so let's look at a problem and then tell me, can I do anything or can I not do anything? What would you do? I've got 2 on the square root of 12 minus 3 on the square root of 27 plus 2 on the square root of 48. What can I do there?
Absolutely.
No, you can.
I hear one absolutely nothing and I hear wait a minute.
Oh.
Well,
Simplify. So like
yeah.
4 square root of 3.
What did I better do here?
Simplify.
Yeah, reduce these radicals. So the 12 is 4 times 3. The 4 comes out as a what?
A
2. So 2 times 2 is 4 on the square root of 3 minus, okay, 27 is what times what?
9 times 3.
9 times 3. The 9 comes out as a
3.
3 times 3 becomes 9 on the square root of 3. Plus square root of 48 is what? 16 times 3. The 16 comes out as a what? 4 times 2 is 8 on the square root of 3. Uh-oh, it looked like I had pineapples and bananas and mangoes, but I really had what? Apple, 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 right? Okay, so what is this? 4 minus 9 plus 8 is 3 on 2, the square root of 3. Boom. Does that make sense? Everybody happy? Okay. Got another one, and I think you guys will really already know how to do this. Okay. What if I had 3 onto the square root of 5 minus 2 on the square root of 3 times 2 plus the square root of 3? How would I simplify that? How would I multiply those together? What would I do? Foil, right? So I'm going to take 3 on the square. Once I start doing this stuff, I don't do it officially foil. I just put my finger here. It's 3 on the square root of 5 times is what?
6 on the square root of 10.
Okay. 3 on the square root of 5 times the square root of 3. 3 square root of 15, right? Now I'll move over here. And I'm going to have minus 2 on the square root of 2 times 2 is minus 4 on the square root of 3. And then I still need to do that. And that is going to be what? Minus square root of 3, square root of 3 is 3 times 2 is 6. Okay? So I've got 6 on the square root of 5. Okay. Minus, yes?
Yeah.
What did you do for the 6?
What's the square root of 3 times the square root of 3?
9.
No.
Square root of 9.
Square root of 9 is 3 times 2,
2.
6. Got it?
Got it.
Okay. This can't be reduced. Nothing can be combined. That's your answer. Can't go any further than that. Does that make sense?
Yes.
Okay. Now I'm going to see if you can tell me what to do, because this is going to be a tough one, and I need you to think. I need you to think on this. Let's say I have 1 minus the square root of 3 over 5 plus the square root of 3. What is my problem?
Square root of 3 on both.
Square root of 3 in the denominator. Now, if you weren't thinking, you would just tell me to multiply the numerator and denominator by what? Square root of 3. But let's see, what would be the problem if I went like
You have
this?
to do
You still have a radical.
yeah.
Yeah, this
You
would
have to do
fix
5
this,
plus
but
3.
because I got to use parentheses, I've just moved it from here to here. That what? That accomplished absolutely nothing. So can you guys, you know I've got to multiply
By 5 plus
the numerator and the denominator by the same thing.
5 plus
5 plus square root?
5 minus 4.
5 minus square root of 3. Right.
Oh, okay.
You're thinking, right? You're
Basically
thinking.
like we did with I.
Yeah, it's like what we did with I. So the kind of like 5 minus the square root of 3, 5 minus the square root of 3. Okay, let's look at the denominator. 5 times 5 is,
25.
and then minus 5 on the square root of 3.
That's fine.
Yeah, you see that's minus 5 on the square root of 3. Then we come here and it's plus 5 on the square root of 3. And then we have what? Minus square root of 9 is what? Minus 3. And so look, that and that makes 0. 25 minus 3 is 22. So I took care of that. Now I just got to come up here and do my bookkeeping up here, right? I got to get this taken care of. So 1 times 5 is 5. 1 minus the square root of 3, so that's minus the square root of 3. 1 times the square root of 3. Now I go to this term, minus 5 times the square root of 3. Is that good? And then what? Plus,
Plus
yeah, plus the square root of 9, which is plus 3. So now look at this. I've got 5 plus 3 is 8. I've got minus the square root of 3 minus 5 the square root of 3. That's what?
Minus 6.
Minus 6 square root of 3, right? I got an apple and an apple. So that's minus 6 on the square root of 3. Now, man, that was really incredible. And we got through all that. Whew, look, we got a good answer. Are we done? No, I got a what? Reduce the fraction. I can take what out of everything? A 2. So that becomes 4 minus 3 on the square root of 3 over 11. Are you happy with that? All right. Homework. Chapter 7, Section 5. Am I right? Are we in Chapter 7?
Yes, sir.
7-5. You're going to do 18 through 35, 38 through 48. The bonus is 62.